Hi, Robin here. Going to look at caching and thinking ahead. This is all related to component 2, but obviously caching is within component 1, so there's a little bit of a crossover here, and can obviously deepen the understanding of the component 1 element. So when we're thinking about caching and thinking ahead, it's important that we understand that they're the same concept. With a cache, we think of it as a memory storage that's trying to quicken up the process by being really close to the processor and using frequently used tasks. And again, we're thinking ahead, we're trying to save time, we're trying to make things more efficient, we're trying to prepare in advance for things we want to do. So we think about this from a human perspective. It's important that we sort of think ahead, isn't it, to how we might plan out our day or plan out an activity or plan out a journey. And we're just trying to think ahead to what things we might need. So for instance, just simple things such as if it's going to rain, we need to make sure we've got an umbrella or a raincoat to cope with that. Other sort of examples of real life scenarios would be something like a chess player grandmaster will learn a series of moves, therefore knows what moves they're going to make, but they also base that decision on what they're predicting their opposition will do, and therefore the sort of outmaneuver their opponent. In many ways, when we think about thinking ahead, it's a strategy, isn't it? It's what's the plan for the future? A snooker player does the same. They don't take the easiest shot. They take the shot that will develop the next series of shots after that. So how does this relate to computing then? So as I've already mentioned, caching is the use of cache memory. The cache memory is very close to the processor, and therefore the distance that the actual data has to travel is tiny. A little bit further away then is RAM, which again is an incredibly quick memory store. So again, the journey distance is small, and therefore both of those two memory types are ready to cope with lots of changes of data, loads of quick data. If you want something to be responded to very quickly, you store it in one of those two places. We could, in turn, save our data further away in places like the cloud or on a server, but then the distance between that and the processor is inevitably further, and therefore is going to be slower as a result. The same concept can also be used in web design, where we can use a cache on websites and scripts. In other words, you're saving time having to send that data across the internet to actually reach that person, and therefore quicken the process. So as you can see from the diagram here, you can see the processor, we've got the cache and the RAM that are incredibly close to it, both part of the motherboard, both part of the process there to make sure that we can have actions that are carried out incredibly quickly. Whereas we then have other types of memory. And again, if you think about the different types of this, we've got the volatile memories of cache and RAM, we've got the non-volatile memories of the hard drive, server and cloud storage, which are designed in a different way. The priority there is to store the data long term rather than speed, and therefore because of that lack of, say, need to make them quick, you're having to factor that into the decision that you're making around how you plan. And therefore, as a programmer, if you're thinking about the actions that need to happen within your software, you need to think about which of those are going to be stored long term, which of those are required on a very immediate basis, and which are perhaps the middle ground where perhaps if that data is being used, such as like a search, for example, that might be a common search within your database, you may store that in sort of a middle ground, such as RAM, while the process is running, so that you can quicken up the access that the user would have to that. And again, all of this can be planned for and therefore programmed for in the way that you sort out your system. So, as I mentioned with a website ultimately, the first time you load a website, everything has to download, and therefore it's going to be the slowest that website will ever be. However, when you've done that, you can then cache. In other words, we can save elements of that web page for future use. So in other words, if you reload that same web page, everything should already be there, and it should already therefore be quicker. If, however, that web page is being updated, parts of it will become invalid, and therefore you don't need those bits anymore, and therefore you need to sort of add in the new fresh elements of that. So that could be anything from images to logos to sort of video content, anything that's going to help keep that website running as quickly and as efficiently as possible. So there are different types and methods of doing this. We have what's called browser cache. In other words, you're saving data on the client side of the process. So in other words, the user's browser. So within your browser, you have memory availabilities within there. You can store different aspects. So we're storing that data on there, like I said, such as a logo or an image or whatever it may be, data or etc. We can also store data within the delivery network, so the CDN. So in other words, if you have a map of sort of servers across the world, what you actually would have is that nearer wherever you live, there will be a server. So for example, there'll be one in London. And therefore, if you're accessing a website that's far away, such as America or Australia or wherever, that once that data is passed into that London server, it can be stored there long term so that the next user can access it directly from London rather than having to go and get it all the way from Australia or wherever it's come from. So it's quickening up the process and just really making it much more slick, isn't it, as a process. Or we can have what's called back-end caching, which is where you're loading that process from the server, but you're doing this for, again, regular actions. So such as a query in a database, you know that there's a common query that needs to happen, and therefore you save that, you preempt it effectively. And therefore it's, again, quickening up the process and making it easier for future users, basically, to give them a quicker sort of function from that server and a better use of the website. So here's a simple comparison, just so you can sort of see some of the differences between them. And again, ultimately, we're trying to think ahead, we're trying to plan ahead. When will I need quick data? When won't I? And then if I will, that's when I want to make sure it's cached in some way. Well, thank you for watching. I really hope you found that useful. Please do check out my other videos and do like and subscribe. It really does help me to help others. So thanks a lot. Thank you.